Hello. Yeah, tell me more about this. Yeah, thank you. Bye. Hello guys, welcome back to the channel. In the last video, we were exploring different types of speech to text transformation models, and these models we were using for various purposes, like an action determination bot using your voice only. So there were like two models that we compared parallelly. One is Vosk, the other one is Whisper, and based on our analysis, we figured out that Vosk, being lighter and pretty much, even though it fails with noise, it is really apt for our particular application. So that's when I decided to go ahead with Vosk instead of Whisper. And this is the application that I built for now. This is like a basically a voice streaming application. Like it always checks for if any voice is coming in, and if the voice is detected, it detects the voice and take the action based on that. So that's what I am trying to achieve here. So let's get down to it. So the basic idea here is to create a voice bot that actively listens to whatever you are speaking, and it detects a pause, and the pause is used to identify the command or like the completion of the sentence and take the action based on the voice command that you have given. So it can be interruptible as well, like when you say the command, you pause something, it starts doing the action, you can do uh, talk again, and the bot is basically listening to that and takes action based on that. Here we have just created some dummy action taken handlers, and this could be basically extended using Whisper as well as other LLM, such that you give an action, the LLM will you take the required action based on the command that you give. So this is the basic outline of the particular application. Here you have the audio input. It goes through some sampling, so basic pre-processing. Then comes in our speech to text model. And once the pause is detected, the action handler makes sure that it takes the necessary action. This is the basic pipeline. So for that, we have a microphone which detects the audio input. Our audio input is using an like default sample rate of our device. So if our sample rate is not equal to 16 kilohertz, we are resampling it, so that our Vosk is basically using 16 kilohertz. So we are resampling. There could be some data loss while we resample the particular voice. So that could be one area where the quality of our model could drop. Once you do the pre-processing, Vosk comes into the picture. It's like really lightweight model, and it can. Why I'm using Vosk as of now is like my end goal hardware is Raspberry Pi, and I want to do a voice activated bot based on Raspberry Pi. That's why I have preferred Vosk. Otherwise, you could go for Whisper locals, Whisper CPP as well, which could work pretty much very well on the local system, but not so good. So here, our Vosk usage is to identify the commands as well as to identify any detections pause. So this pause detection is what it is used to understand if it is an intermediary input or if there is any pause or if the command is complete. So once the pause is detected, we have given an interval of 700 milliseconds. So 700 milliseconds of pause is said to be an end of user input. So whenever the end of user input is met, we can stop the playing around. You can just say, okay, this is my final input. You can just take the action based on the text given. So this text that is being recorded is streamed into the LLM, and this LLM can take the action based on that. Right now we are not using any LLM as of now. We are just using an action handler. We'll get on with that. So here is the basic action handler command I have used. So the basic text is to if the detected text contains turn on, turn off, status. So basically, it is just to simulate the voice command application, but it does not work that way as of now. But we can improve it over the time. So this is the full system overflow. Then here, as you can see, there is a mic that is listening to live audio. Then there is Vosk that is streaming the transcription, and there is the post editor. If the turn is completed, it is given to the action handler. The action handler take the actions, and the whole loop is completed. You can listen to the mic start listening again. So that's what basically happens. So basically, once you have written this particular application, you can extend this to meet the limitations. For example, longer text can be handled by Whisper. We can use LLM to take better actions and text to speech. In case like LLM, if you want the LLM to talk, if you want a Raspberry Pi to talk back to you, those kind of things could be done. But here we are not using that as of now. So here what we have achieved is a real-time voice bot which listens to you, takes actions, you can interrupt, and for the future scope we can integrate some LLMs as well as Whisper to improve the model's performance. That's it. That summarizes the whole video. I will get deep dive into it once I fully complete the application. This is like an intermediate state. So if you like the videos, technical videos like AI, technology, engineering, do subscribe to channel, and if you like this video, just give a thumbs up as well. So bye. Thank you.